Good morning. My name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. Our lesson before was on calculating your n using Slowin and Cochrane's formula. We will be using that later to apply that in selecting the sample units. So we have our n and now we have to select our sample. But there is a procedure because we cannot have selection bias when we get our sample from our population. There is a procedure. So the first procedure is simple random sampling. Uh, Simple random sampling selects size of n by methods that allows each possible size of n have to have an equal likely chance or equal probability of being considered. So if you have 50 students or 50 respondents and you only need to get 5, there's a procedure on selecting them. You cannot just select, oh, I'll just get this 5 and that's it. It has to be calculated in a manner that is all of them are given equal chance to be selected. So let's take an example of this one. So a company employs 58 full-time employees. To gain the employees' opinion about upcoming contract negotiation, the president of the union wishes to obtain a simple random sampling that will consist of 5. Take note that it is a decision that if the president wants to get 5. We're not using Cochrane or Sloven's formula in getting the number of samples. This is just an example, but it can be done also as discretion because it's probably the limit of what he can achieve, or he only needs 1 or 5. So, how will you help in selecting committee members by selecting sample and sampling? Okay. So let's go at this one. So let's look at the Excel. So we have our n, which is 58, and a sample of 5. So our count or our interval is G3, G2, which is 58 over n, that is 11. So in simple random sampling, so the procedure is, one of the procedure is, from the list of names, the president closes her eyes and drops a pencil on the list. From the starting point, the president counts based on the interval n over n case. So in this case, let's say the pen dropped in respondent number 4, or let's say number 8. No, respondent number 8. So it becomes the respondents are, first respondent is respondent number 8 on the list, number 20, 31, 43, and 54. So those are your respondents. The problem here is when it becomes, for example, the pen fell to a much bigger number, and let's say 30. And you will notice that there is no respondent number 65 or 76, simply because the count changes. The count is 58, then you have to count back to number 1. So what you'll do is to just simply 68 minus uh 58, because we have to count back to 1 again. So respondent number 7. Okay? And from that, we'll just count again. 68 from respondent number 7. We'll add interval again of 11 and 6. So our next respondent is 18. So we have respondent number 30, 42, 53, number 7, and number 18. So those are your respondents or your sample using simple random sampling. Another method is that is similar is systematic. Systematic sample is obtained by selecting every k from an individual population. The first selected individual selected corresponds to a random number between 1 and k. Oh, steps in systematic sampling. Make sure that you have a finite population and enumerate each individual. decide how large your sample will be, which is n, calculate the interval, and randomly select between 1 and k. So our k is also known as our interval. So let's say our first count is a number is 11, so or 12. We can only the first respondent is any number between 1 and 12. You cannot go beyond any number between 1 and 12. Let's go to number 6. So your first respondent is respondent number 6. Then you have respondent number 18, respondent number 29, 41, and 52. Since in systematic sampling you cannot go beyond 11, you will always have this proper count. You don't have to be like this one that you have to minus it from the n. And I think this one is easier because this is too random. What if the head fall at 58? So when you now you have to count back again. So that's 58. So that's respondent number 12. And from 12 you count there, and then you change it again. So it's tasking, and so these are your respondents. Respondents number at number 58, 12, 23, 35, and 46. So that's how you select your samples, not just randomly. I need five, so one, two. The four of you come here. We'll do research now. It's not that how it goes. So from simple random sampling and systematic sampling, you also have cluster sampling, which will also utilize simple random sampling and systematic sampling. So let's read through this. What is a stratified sample? A stratified sample is obtained by dividing the population into separate homogeneous categories or groups that do not overlap. They are called strata, stratum in singular. And it takes simple random sampling from each stratum. These subsamples will form a stratified as needed. So a cluster sampling is obtained like stratified sample by dividing the population into groups, obtain a simple random of the group as a whole, and select the individuals within randomly selected group or stratum. So let's look at this one. Example, there is a firm of 300 employees with different departments. You would like to have a committee representing the department. The groups here are the different departments represented by the different colors. We have very dark gray, light gray, and very light gray. The strata are the different sections in the department. The cluster is the different departments. Let's say there are 5 departments of different number of employees per department. The the departments are your cluster. Thus, you can decide how much you want from the department and confidence level of no, you can calculate for n and the confidence level of 0.05. In this case, we are now using Sloven's formula. We have our level of confidence, level of significance of confidence level, and we have our n. So we can calculate our sample size using Sloven. So we have n, which is 300, our e at 0.05. So this one is our denominator 1 plus n e squared. And our result, our n, is just our n, which is 300 over 1 plus n e squared, which is 171. So we need to get 171 respondents from our 300 respondents to have a confidence level of 0.05 or levels of let's say you are 95% sure or confident of the responses based on the sample. So let's say you have 60 employees in the first department, 52, 60, 38, and 90. They are not equal numbers. So the question is, how much are we going to get per department? So we just simply divide our n over our population and we will have 57%. So we only need 57% of the first department and each department, and that is equals to 60 or our 60 multiplied to our percent. So we have 34 respondents, 30, 34, 22, and 51, which will equal to which will be equal to 171. So from that, we can now go to this simple random sampling in selecting our respondents or systematic sampling. Let's try to use systematic sampling so we don't go over the threshold. So we have our n is 300, our sample is n. Okay, what happened? No, our sample is not. Our sample is n, but in this case we have 171. So the first respondent is a number between 1 and k. A number between 1 and 1 is 1. So, and then we have our list. So these are the first respondent, second respondent, third, fourth, fifth, and so on and so forth till you get the 34 respondents from the first department. So that's how you get your units or your respondents based on the list. So I said again, I'm gonna say it again. You don't just select. You have to have a procedure. One is simple random sampling, and the other is systematic sampling. I hope you learned something from this lesson. I will be giving more lessons soon. Our next lesson will be on types of measurement, and yeah, I'll be giving lessons of the entire book. It will be soon be published around mid February or end of February. I hope you'll like and subscribe to this channel and hopefully purchase the book in the future. So thank you and have a great day.